In this pod, we'll investigate the variation of the volume of a gas as the temperature changes.
In a gas, the particles are free to move around at random. If the temperature of the gas increases, then the particles gain more kinetic energy, move around faster, and occupy more volume. The volume of gas has increased because the temperature has increased. You can see examples of this in real life. If you heat a packet of food in a sealed plastic bag without piercing the bag will swell as it is heated. This is because the air inside the bag has expanded as it was heated.
Imagine you fill a balloon with air at room temperature, seal it, and put it into a fridge. You can leave it in the fridge until the air inside the balloon has cooled to the temperature inside the fridge. Now, when you take the balloon back out of the fridge, you will see that the size of the balloon has decreased. This is because the volume of the air inside the balloon has decreased. If you hold the balloon near something warm, it'll expand again.
The law that explains the relationship between the temperature and volume of a gas at constant pressure is called Charles's law. Charles's law states that for a fixed mass of gas at a constant pressure, the volume is directly proportional to the absolute temperature. In other words, V divided by T is a constant.
Absolute temperature is the Celsius temperature plus 273. Absolute temperature is measured in Kelvin, which has the unit capital K. The absolute temperature scale starts from absolute zero. Remember, all gas calculations must use temperature in Kelvin.
You can investigate the relationship between volume and temperature by heating a volume of air in a sealed cylinder, as shown in the diagram. As you heat the air inside the cylinder, the volume increases and the pressure remains constant. Record the temperature and volume in a table. Plot a graph of temperature on the x-axis and volume on the y-axis. Your graph should look something like this.
Plot your results to the right of the zero on the temperature axis. Then draw a dotted line to the left in the negative direction, continuing the line shown by your results. Your dotted line should cross the temperature axis at around minus 273 degrees Celsius, which is 0 Kelvin. Remember, all gas calculations involving temperature use the Kelvin scale.
As we mentioned before, V divided by T is a constant. This means we can expand it to show that V1 divided by T1 equals V2 divided by T2.
If you know the volume V1 and the two values of the temperature, T1 and T2, but do not know V2, you can find it by rearranging the equation. V2 equals V1 multiplied by T2, all divided by T1.